Mars, the red planet, has captivated human imagination for decades. For generations, we've peered through telescopes, watching that rusty point of light traverse the night sky. We've dreamt of what it would be like to stand on its surface, to search for life, to plant a flag and call it a second home. But what would it take to actually colonize it, to transform this alien world into a habitable planet for humans? The challenges are enormous, but so are the potential rewards. Imagine a future where humans are no longer confined to a single planet, where we've expanded our reach into the cosmos, becoming a multi-planet species. Let's explore the journey step by step, examining the hurdles we must overcome, and the technologies that might just make it all possible. The first step on this extraordinary journey is, of course, getting there. With current technology, a one-way trip to Mars takes around 7 to 9 months, a long and arduous journey across the gulf of space. But imagine a new era of spacecraft, like SpaceX's Starship, designed to ferry humans and supplies back and forth on a more regular basis, making these trips not only faster, but more cost-effective and sustainable. But arriving at Mars is only half the battle. Landing safely on an alien world with its thin atmosphere and unforgiving terrain is no easy feat. Think of the precision required, the delicate dance of thrusters and parachutes, all while battling the forces of gravity on a planet far from our own. Once we touch down, establishing a base of operations becomes critical. We're not talking about planting a flag and calling it a day. We're talking about creating a foothold for humanity on a new world. Picture a fleet of autonomous robots tirelessly working in the Martian dust, preparing the way for human arrival. These mechanical pioneers will be tasked with constructing the first rudimentary habitats essential for safeguarding early colonists from Mars' extreme environment. Imagine these habitats, gleaming like beacons in the Martian landscape, built to withstand the harsh realities of this alien world. Creating a true home on Mars requires more than just survival shelters. We need habitats that nurture the human spirit, that provide a sense of comfort and security in this alien landscape. Imagine spacious domes bathed in the warm glow of artificial sunlight, mimicking the day-night cycle we're accustomed to on Earth. Inside these domes, life would flourish. Hydroponic gardens, verdant and teeming with life, would provide fresh food and a welcome splash of color. Common areas designed for socializing and recreation would combat the isolation of living on another planet, and private quarters, personalized and comfortable, would offer a sanctuary from the challenges of Martian life. Transporting materials from Earth is simply not feasible on a large scale. Instead, we have to utilize what's already available. Martian regolith, the loose rock and dust that covers the planet's surface. We can mix Martian regolith with binders, perhaps even using advanced 3D printing technologies to create strong, durable structures. Of course, these habitats must be pressurized to mimic Earth's atmosphere, allowing us to breathe freely without cumbersome spacesuits. Just like on Earth, a thriving Martian colony depends on a constant and reliable source of energy. Without it, our life support systems fail, our lights go out, and our dreams of colonizing another world fade into the cold darkness of space. The most obvious source is right there in the sky, the sun. Solar panels, spread out across the Martian landscape, could harness the sun's energy to power our habitats and infrastructure. Imagine vast fields of solar panels, soaking up the sunlight, converting it into the energy that will keep our lights on and our machines humming. But Mars presents a unique challenge: dust storms. These planet-wide events can blanket the surface in a thick haze, blocking out the sun and rendering solar panels useless. We need a backup plan, a source of energy that can provide consistent power, even when the sun is obscured. That's where nuclear power comes in. Small, modular nuclear reactors could provide a safe and reliable source of energy for Martian colonies. These reactors, designed with multiple layers of safety protocols, would generate power independently of the sun, ensuring our survival even during the harshest Martian storms. We can't survive on freeze-dried food and packaged supplies forever. To truly thrive on Mars, we need to establish a self-sustaining food supply, one that can nourish generations to come. Transporting food from Earth across millions of miles of space is simply not sustainable in the long run. It's expensive, it's inefficient, and it leaves us vulnerable to disruptions in the supply chain. We need to grow our own food on Mars, utilizing the planet's resources to create a closed-loop system. We won't be planting fields of wheat in the Martian soil, at least not at first. Instead, we'll turn to innovative techniques like hydroponics and aeroponics, growing plants without soil, using nutrient-rich water solutions instead. Picture this: vertical farms, bathed in the glow of LED lights, where rows upon rows of leafy greens, vegetables, and even fruits flourish in a carefully controlled environment. These farms, stacked vertically to maximize space, would utilize minimal water, a precious resource on Mars, and be shielded from the harsh conditions outside. Back on Earth, scientists are already hard at work, experimenting with these techniques, adapting them for space use. They're developing special lighting systems that mimic the spectrum of sunlight, optimizing plant growth. We can dream of Martian cities and sprawling farms, but without two fundamental ingredients, those dreams turn to dust. Oxygen, the very air we breathe, and water, the elixir of life, are non-negotiable for human survival. We can't ship them from Earth forever, it's simply not feasible. We need to find ways to generate these vital resources on Mars itself, to unlock the secrets of survival on this alien world. Let's start with water. The good news is, Mars isn't completely dry. It harbors vast reserves of water ice, locked beneath its surface and frozen at its poles. Tapping into these reserves, extracting that ice and purifying it, would be a game-changer for Martian colonists. Imagine robotic explorers drilling into the Martian crust, extracting that precious ice and transporting it to processing plants. There it would be melted, purified, and finally delivered to our habitats, ready to quench our thirst and nourish our crops. But what about oxygen? The Martian atmosphere, thin and unbreathable for humans, is primarily composed of carbon dioxide. NASA is already testing technologies like MOXIE, the Mars Oxygen In Situ Resource Utilization experiment designed to convert carbon dioxide from the Martian atmosphere into breathable oxygen. So far, we've focused on surviving on Mars, on carving out a niche for ourselves on this alien world. But what if we could go further? What if we could re-engineer the planet itself, transforming it from a cold, dry desert into a world more like our own? This is the audacious goal of terraforming, a long-term process of planetary engineering that could, one day, make Mars a true second home for humanity. Imagine a future Mars where the skies are no longer a dusty pink but a vibrant blue, streaked with clouds. Imagine rivers flowing through verdant valleys, forests stretching across the land, and vast oceans teeming with life. It sounds like science fiction, but the principles behind terraforming are rooted in science fact. The key lies in understanding the greenhouse effect. By releasing certain gases into the Martian atmosphere, we could potentially trap more of the sun's heat, warming the planet and thickening its atmosphere. This in turn could melt the polar ice caps, releasing even more water vapor into the atmosphere, further accelerating the process. But terraforming Mars is not a quick fix. It's a multi-generational project, a testament to the long-term vision and ambition of humanity. The path to colonizing Mars is paved with challenges, obstacles that will test the limits of our technology, our ingenuity, and our very resolve. We're talking about sending humans to a planet with a hostile environment, where every breath of air, every drop of water, every moment of safety must be carefully engineered. Let's start with the journey itself. Confining humans to a spacecraft for months on end, hurtling through the vastness of space, presents a myriad of psychological and physiological challenges. Imagine the isolation, the confinement, the constant stress of being so far from home. We need to develop countermeasures to ensure the physical and mental well-being of our Martian travelers. Then there's Mars itself. The lower gravity, while a novelty at first, could have long-term effects on human health, weakening bones and muscles over time. We need to find ways to mitigate these effects, to keep our bodies strong and healthy in this alien environment. And we can't forget about radiation, a constant threat on a planet with a thin atmosphere and no global magnetic field. Exposure to cosmic rays and solar flares could increase the risk of cancer and other health problems. Shielding our habitats and developing protective gear will be crucial for the long-term survival of Martian colonists. Colonizing Mars will be the ultimate test of our ingenuity and resilience. It's a monumental undertaking, fraught with challenges, but the rewards are immeasurable. It's not just about survival, it's about pushing the boundaries of human exploration, of expanding our reach into the cosmos. Imagine a future where humanity is no longer confined to a single planet, where we've established a permanent presence on Mars, a testament to our indomitable spirit. Imagine children, born on Martian soil, looking up at a night sky where Earth is just another point of light, a reminder of where we came from and how far we've come. Are we ready to take the leap? The answer lies not in the stars but in ourselves, in our willingness to dream big, to embrace the unknown, and to boldly go where no one has gone before.